screen. It's a pity because it isn't the start of a very important section. Suppose I should have expected that though. Okay. Can you guys see my screen? I think you can. Yeah, cool. Cool, let's get started then. Okay. Present. Right, so today we're going to be covering a super important topic, object-oriented programming. But we are going to revise methods quickly first, and then we'll jump into object-oriented programming, because otherwise it might be a bit too confusing. You make sure, double check again. Still none. Okay, that's a pity. Yeah, I guess we have waited long enough though. I take it the late people are just late because, okay, I must remember to always post on the group in the morning that we're doing it in the afternoon. Okay, so this is how methods worked. Okay, so we say public, static. We haven't really explored what those words mean, but by the end of today's lecture you will know what they mean. You give it a specific type, and that specifies what the type of this variable that it's returning is. Okay. You also have to specify a name for your method, and you have to specify all the variables that are passed into the method. Okay. So this is one example that we saw. Okay, so we have our main method as usual. Okay, public static void main. We say int x equals 3. Okay, so we're just creating an integer there called x. Its value is 3. We say console.writeLine, so we're printing something out, and we call function x. Okay, now the computer obviously initially doesn't know what function x is, so it goes and it looks. It goes and finds the method called function. Okay, so that's why it's important for you to specify a good name for your function. So this one was just called function. So it would have gone through, it would have seen main is not function, and then here it would find the method function. Okay, immediately it will see that function takes in an integer that it calls a. Okay, so function calls the integer a. Whatever integer you give it, the first one, it's going to call it a. Okay, outside of the function you can call it whatever you want. Okay, so here we call it x. But inside the function it takes in an int and it calls it a. Okay, so we gave it x, which value was 3. Okay, so we said function x, so we gave it 3 and it would immediately save 3 into a. Okay. Also immediately, as soon as the computer finds function, it's going to see that it returns an int as well. So it's going to expect that when it calls function x here, function x is going to be replaced with some integer. Okay, that's what this little one here is saying. It's saying, okay, when this function finishes, it's going to return something of type int. Okay, so when we go into the function, it just goes return a times a. Okay, a is an int. Okay, its value is 3. 3 times 3, that's 9. And 9 is an integer, right? So it will go console.writeLine, and function x will be replaced with 9. Okay, 9. And then this will just print out 9. So that's one method that we saw, and we played with a few other methods. Okay, good. Some more people have joined us. That's nice. Yeah, okay, I must really remember to post on the group every morning. Jean-Marc, did you also forget that it was going to be today because I scheduled it last? Yeah, that function is just for squaring, Tadi, that's correct. Yeah, it just multiplies whatever number you specify. So you go function, and then inside the brackets you give it some integer, and whatever integer you give it, it's just going to square that. Oh, you are at the shops. Okay. Okay, that's short, I guess. So yeah, that's a function for squaring. Yeah. Or yeah. Cool. So that's a method, and we played with a few other methods as well. We played with methods that just print things out, and we did a bunch of things. I suppose we could go into Rex Tester now and write one more method just to make sure that we've really got the concept down. I think that might be beneficial because it has been a while. Yeah, okay, cool. So L agrees. Okay, cool. So I'm just opening up Rex Tester. I'll post it in the chat for you guys as well if you want to use it too. You can also still use .NET Fiddle if you prefer it, or you can use anything you've downloaded locally too. Okay, so I'm gonna make this full screen. Alright, so we've got our main method here, right? And here we would put whatever code we want to run usually. Okay, so what method should we make? Should we make a method that takes in 2 integers and adds them together? Okay, so it takes in 2 integers and it will add them together. That's the method we're going to make. Alright, but for now let's just set up our main method. So, you know, as usual, whatever code we put here will just be run. So I've written hello world here into main, and so this will just run the main method. Okay, and the computer will always run the main method first. So when I hit run it, why it requires me to log in now? That's very weird. Really? Huh. Okay. That's new. Wow, it still has Google Plus login. Amazing. Cool. Okay, we now have a Rex Tester account. Wow, it changed a lot, eh? They've done some updates recently. Alright. Cool. So, sorry about that brief interlude. Okay, so when I run this, you can see it goes hello world. Fantastic, right? Cool, so we've got this. This is quite cool now because I think we will be able to share code through this as well. So that could be quite nice. Okay, so I've got my main method here, right? And we say we want to create a method that adds 1 to... Tuddy, if you don't feel like logging in, I mean, it worked quite nicely with just using my Google account. .NET Fiddle will still be as it was before, right? So you can use .NET Fiddle and that will be... and you won't need a login for that. Okay, cool. So we've got our main method, right? We want to create another method that adds 2 numbers. And let's just say we're going to call this method adds 2 numbers. Okay, so as usual, we're going to make it public, static. Cool. So now we have to decide what type it's going to return. Right, so we're going to write this method in 2 different ways. And just so that you can see really what this typing is for. Okay, so initially we're going to say it's the same as the main method. Okay, it's going to have void, so it's not going to return anything. That's what void means. It means this method will not give back, it will not pass back, it will not return anything. Okay, and we're going to call it add 2 numbers. That's the name of our method. Okay, and just to get the normal structure up, so I put 2 normal brackets and then 2 curly brackets. Okay, so the code inside my method goes in the curly brackets, and these normal brackets we'll say what we need to take into the method. Okay, so if I go back to our slides quickly, so here, let me go to the main slides actually. Yeah. Okay, so if I go back to the slides here, you can see this method that we created before, it took in 1 integer, right, a. And obviously if we were just squaring the number as Tuddy pointed out, so we're multiplying the number by itself. So we only need 1 number, right, int a, and then we just returned a times a, right? So we only needed the 1 number. But now we want to add 2 numbers together. So we're going to need 2 integers, right? So here we just had int a. Now we'll need maybe int a, comma, int b, or int x, comma, int y. We can call them whatever we want, but the point is we're going to be taking in two integers because we want to add them together, right? Cool, so hopefully we get that. I think it might be good for me. Okay, so yeah, that's fine. Let's so we need to take in two integers as mentioned. So here in our normal brackets we're going to say int a, so that's taking in one integer now, just like our last thing, and it's called a. And then we would say int b, right? So now it's taking in two integers, and it's quite clear to see that it's taking in two integers, right? And as I said, you can call these whatever you want. You could call it int x, int y, or you could call it int num1, int num2, whatever you like. I'll stick with num1, num2, so number 1, number 2. Okay? Cool, so that's the basic outline of our method. We've now created a method, and we just need to say what it does now. Okay? So what we want this method to do is we want it to add number 1 to number 2, and then let's say it must just print out the numbers. Okay? So I'll say int answer. Okay, I'll answer what is the value. Okay, we'll say equals obviously num1 plus num2, right? Num1 plus num2. Okay, so that will produce the result we require, and then we want to print it out. So we would just say console.writeLine answer. Okay. Cool. So that's our method. We also have to explore, okay, now how do I call this method? Okay, so the code in main, as we just saw, is what is run, right? So if I ran this now, and you can see if I ran this right now, nothing would happen. Okay, it won't print out anything. Okay, why won't it print out anything? Because only main is run, right? And main is doing nothing at the moment. Okay, so we need to tell main to go to this method add two numbers. We also have to give it the two numbers that add two numbers requires, and then this will happen. Okay, then it will actually run this code. So how do we tell main to go and run add two numbers? Well, we just say add two numbers, right? Okay. Currently, if I ran this, it would complain, right? And we can see if I click run here, it goes errors, there's no argument given. Okay, so it's saying you have to give it num1. Okay, you have to give it num1. You see, that's what this error is saying. The required parameter num1. See, it requires num1, you haven't given it num1. Okay, so let's say I gave it num1. I go, okay, it's 5. Num1 is 5. This still won't work, right? Because now it's going to require num2. So if I hit run on this, it goes, no, that you haven't given an argument that corresponds to the required parameter num2. Okay, so you have to give it a num2 as well. So I give it its two numbers, and now it is just going to go, okay, add two numbers, 5, 6. So num1, num2. Num1 is 5, num2 is 6. It'll come here, it'll say int answer, create a new variable called answer. It's going to say 5 plus 6, okay, 11, and then it's going to print out 11. Alright, so when I run this, you can see it prints out 11, and that works great. Okay, so that's a simple method. Pretty good. Everyone's still following, I hope. Yep. Cool. Feel free to. Doesn't work. Are you sure? You could just be typing it incorrectly. I can show you. It will work. Let me just. I'm gonna just pull that into the same window because it's a bit easier to navigate that way. Okay, so let me go to .NET Fiddle then, and we can reprogram it there. Things might look a little bit different, but it's still C#, right? So it will work. I'll show you now. Okay, so we've got our class program. All right, so I'm going to come here. I'm going to create the same method. We're going to create exactly the same method. Okay. So I'll say public static void, and we can say adds two numbers, okay, like that. Okay, cool. We want to take in two numbers, right? So we'll say int a, int b. Okay, this time I'm calling them a and b. Remember, you can call these whatever you want, but when you use them inside the method, they have to have the same name. Okay, so int a equals int b, and I mean int a and int b. Then I'll say int answer equals a plus b. Okay, and then I'm going to say console.writeLine answer. Okay, so we've just changed the variable names here, right? I called them num1, num2 inside Rex Tester, and here I'm calling them a and b. Okay, but it's no big deal. Then I say adds two numbers. Okay, and I'll give it its two numbers, 5 and 6. And when I run this, it prints out 11. Okay. Cool. Did you find what your error was, Tuddy? What was happening? It's easy to make little mistakes. So cool. Ah, missed a symbol. Okay, yeah, I mean, all good, all good. All right. Cool. So we created a basic method. Okay. So can you go back to the code? Yeah, sure. I'll make it full screen. Okay. Cool. So while you guys copy out the code, if you're interested in doing that, so this was just revising methods, right? We've seen methods before. That's not actually the main focus of today's lecture. Okay. The main focus of today's lecture is the overall structure of this code. Okay. So where is this add two numbers method? Okay, so let's look at what C# sees here. First, it sees in this case on .NET Fiddle there is no namespace. Okay, there is no namespace on .NET Fiddle. You still have the class program though. Okay, but it sees, okay, there's a namespace called Rex Tester. Inside that namespace there's a class called program, and inside that class there is adds two numbers. Okay, so I do just want to show you that this is not just for show. Okay, the namespace and the class, it's not just for show. C# does know what these mean. So to show you, this, bear in mind, what I'm going to write now, it doesn't change anything. It's the exact same thing. Okay, if I go program dot add two numbers. Okay, so you see I said program dot add two numbers. So you see, where does this program come from? Public class program. So if I say program dot add two numbers, this is the same. It's going to this method. So this does the exact same thing. So you can see if I go and run this, it does the exact same thing. Likewise, you see in Rex Tester, this is in the namespace called Rex Tester. You won't have a namespace in .NET Fiddle. It doesn't give you one. But in Rex Tester, we've got this namespace Rex Tester. Okay, so I could say Rex Tester dot program dot add two numbers. See, like that. And if I ran this, you can see it's the exact same thing. Still just prints out 11. And if I change these numbers here, that'll just change what it prints out, right? So now it'll be 13. Okay. Cool. So I did just want to show you that, like, there is some structure to this, right? Inside Rex Tester, we have a class called program, and inside that class called program, we have add two numbers. And to show that, you can go Rex Tester dot program dot add two numbers. In .NET Fiddle, you could do program dot add two numbers, and you'll see that it will still just call the method you just made. Okay. Cool. So you can see it's inside the class, and it's not just for show. C# actually sees it as this. Okay. Cool. So I'm going to remove that quickly, and let's just see now what we can do instead of void here. Okay, so notice that I'm printing out answer here, right? I go console.writeLine answer inside the add two numbers method. Okay, you can see this isn't what we were doing inside the slides. So if I go back to our slides quickly, you can see that in our slides, console.writeLine function x, console.writeLine, it's inside the main method. Okay, it's not inside the function method. Right, you see it's here. And the function method doesn't print anything out. It just returns the results that you wanted. Okay, just returns the result that you wanted. So let's make this do that instead. Okay, let's make ours return the result rather than printing it out immediately. So what I want to be able to do is replace this console.writeLine and instead say return answer. Okay, answer. Okay, yeah, there we go. So I say return answer. Okay, this won't work currently, right? So when I run this, it'll say program.add2numbers int returns void. So you see it returns void. Okay, it doesn't return anything, right? That's what that means. Returns void. It's supposed to return nothing, an empty thing. Okay, nothing. So how do I make this work? Well, I need to tell it that we're no longer returning void. We're returning answer. Okay, we're returning answer. More specifically, I need to tell it what answer is. What is the thing we're returning? So if I go and look at the line where we create answer, I say int answer. Okay, so answer is an int. So instead of void, I'm going to have to put int here, right? So now it knows that this method returns an int, and when I run this, it now works. Okay, so now it knows that it's returning an int, and you can see that it works. Okay. Cool. There's another problem here now, because we're not printing anything out anymore. So here I'm just going to show you, you can use this now as a normal value. Whatever value this method returns will just replace this line here. This add two numbers 76. That little thing there, you could see it as a placeholder almost for the value that the method returns. So you can see if I go int, so now I'm inside the main method. Hey, I'm doing this inside the main method. I go int answer. Okay, answer doesn't exist here yet, right? We created answer here inside the add two numbers method. I'm creating another variable here called answer. I could also call it x, whatever I wanted. Equals add two numbers. Okay, so I'll say int x equals add two numbers, or int answer equals add two numbers, or int number, whatever you wanted. You can call this whatever you want. Okay, you're creating a new variable here, and inside it you're saving whatever add two numbers returns. Okay, and now I could go ahead and print out that number. Okay, so now you see answer doesn't print it out anymore. I mean, add two numbers doesn't print it out anymore. It returns it. So it returns it back to here. That gets saved into our number variable, and then we print out number. Okay, so this now goes and it'll print 13. Alright, because 7 plus 6. Let's see what people are asking. So return is like an abbreviated. No, not really, because it doesn't print anything out, right? So console.println is a method that prints something out. So you give it the thing you want to print inside the normal brackets, exactly like we gave our methods their integers. You just give console.writeLine anything you want to print, and it'll print that out. Return gives back to the calling method. So whatever I returned here, what calls it will just be replaced by this. Okay, so it's a way of giving back. It's saying, okay, we're inside add two numbers now. It adds the two numbers together, and then it returns the value. Okay, it gives back this as an answer. So you can almost think of it like this. Main was going, hey, add two numbers. Can you add these two numbers together and give me back an answer? Okay. Return answer, the return is what's telling the computer to go, okay, give this back as the answer. Okay, That's what return is doing. It's saying, okay, add two numbers. You've finished adding the two numbers together. Now return the answer back to main. Main asked you the question, and now you have to return the answer to main. Okay, and you could return whatever you wanted here as long as it was an int. Okay, if we wanted to return a string, then we would just make that string. Okay, so remember that return isn't printing anything out. Return isn't printing anything out here. We still have to call console.writeLine to print something out. See, if I don't call console.writeLine there, nothing will happen. Nothing returns. Number has add two numbers 7, 6 saved into it. It is 13. Number is 13 here. But without calling console.writeLine, it won't print. So they're totally separate. Okay, totally separate. Cool. So okay. Awesome. So that's our revision of methods. If anyone has any other questions, go ahead and think of those, and you can ask them in the chat, and I'll answer them. But I think with that revised, let's get on to the main topic of today's lecture, okay, which is object-oriented programming. Let's see, did more people? No. Oof. Okay. Cool. So, what we're going to explore today is how the structure works in more detail. Okay, so this namespace, class, method. Okay, how does this actually work? How do we create our own classes? And just what do all of these words mean, like public and static? Okay, we know what this word means now. This is the type that the method returns. So you can see main is void. It doesn't return anything. And you can see there's no return statements in main, right? Whereas here, add two numbers, it returns an int. So it has the word return followed by a thing that is an int, right? Answer is an int. Okay, let me move this, sorry. Okay. Cool, so let's continue with object-oriented programming, alright. Sorry, I just want to more comfortable this way. Okay, cool. So, object-oriented programming, what is it? Why do we have it? That's what this sort of first slide is devoted to. And I think a good way to think about object-oriented programming generally is to think about actually just how you think about the world. Okay, so if you look at the world contains a bunch of different things, you know, almost infinitely many things, right? Plenty and plenty of things. Birds, trees, desks, people, lecturers, students, and so on and so on. Okay, the world contains a bunch of different things. Let's see, is that a question? Yes, that is true. Okay, and they all interact with each other simultaneously. Okay, so we're going to call these things objects. They all interact with each other simultaneously, all these different objects. Okay, the problem that we run into when programming is that computers do not contain these objects. Okay, they do not contain all these different things. They just contain lines of code, right? Usually, especially when computers originated, it would just be lines of code, and each line of code runs sequentially, right? One after the other. Things don't happen at the same time. The computer's never doing anything at the same time as other stuff. It's always just going through things one at a time, one line by one line by one line. Okay, so in many ways you could see it as the direct opposite of what the world is actually doing, right? The world has these objects that interact with each other, and the computer just has these singular statements that run one by one rather than acting all simultaneously. Okay, so object-oriented programming is a way for us to program in the first way instead of the second way. Okay, so we're able with object-oriented programming to create all of these different objects, and they can all interact with each other, instead of us just having lines of code that run one after the other. Okay, and that's a much more intuitive way to think about things for humans, right? If I was, let's say, creating a program that rendered a forest to your screen, for example, so I wanted it to render a whole forest of different trees, and there might be birds flying between the trees as well. I wouldn't want to go through and program every single line, right? I wouldn't want to go, okay, tree 1 equals this, tree 2 equals this, tree 3 equals this, and go through and create every single tree individually, make sure that each one individually renders in the exact same way, program each of the little birds and the leaves and everything, make sure everything's working like that. That's not how we would approach that, right? When a human thinks about it, they'll go, okay, we have these things, trees, I can picture a general tree. We have these things, birds, I can picture a general bird, and I'll just create a bunch of them, and they'll all just be slightly different, right? They'll all just be slightly different, but they all have leaves, they all have bark, they all work, and all the birds have beaks, you know, they all work in the exact same way. They're just slightly different in some, you know, fairly easy to think about ways. Okay, so don't worry if that's a little bit scary to you now. I think after the next sort of 2 slides, you'll have a pretty intuitive understanding of what I mean by this. Okay, but this is why object-oriented programming exists. Okay, so when we're trying to program like this, the primary concern we have is, okay, how do we program objects? How do I explain to a computer what one of these objects is? Like, what's a bird? Okay, like, for example, how would I tell a computer what a person is? Okay, quite a difficult question, obviously, especially if you're being very specific, but you'll see that we don't have to be specific in order to do some very powerful things, if you like. Okay, so this is how we might describe objects as a human, and you'll see that the structure of classes and methods and properties, it's a very sensible way to describe objects. Okay, a very intuitive way to describe objects. So let's say we have 3 objects here, 3 people in this case. Each of our objects is a person. Okay, so we've got 3, you can see the 3 little people on the slide there. Each of them is an object. Okay, all of our people, they'll have different hair colors. Okay, so you can see the person on the far left has blue hair, person in the middle has blonde hair, person on the right is brunette. Okay, cool. Each of our humans also has a height. Okay, so 1.8 meters on the left, 1.6 meters in the middle, and our person on the right is a giant, they're 3 meters tall. Okay, so each of our people also has a height, and each of our people also has a weight. Okay, 70 kilograms, 75 kilograms, 200 kilograms. Okay, so we have 3 objects. Now you can see that all of these objects are actually identical, right? They're in a sort of abstract sense, they're identical. Yeah, they have different hair colors, they have different heights, and they have different weights, but otherwise they're all the same, right? They all have the same properties. Okay, those are what we call properties, or same attributes. They all have a hair color. We don't necessarily know what that hair color is, but they all have a hair color, they all have a height, and they all have a weight. Okay. Yeah. 3 meters, and yeah, he's ginormous. Okay. So we've got cool. So we've got these 3 people. Okay, they all have hair color, height, and weight. Okay. So cool. Good on that. So we've got these 3 objects, and they each have these 3 properties, and the properties are what makes them unique. Okay, that's the important thing to grasp here. Okay, they're identical except for the values of their properties. Okay, so hair color is a property that can make one of these people unique. Okay, height is a property that can make one of them unique. Weight is a property that can make one of them unique. And I also immediately now I want you to start thinking about, like, okay, how would I store 1.8 meters, right? Or specifically 1.8. What is that? That's a double, right? I could store that in a variable. 70 kilograms, 70. That's an integer, right? I could store that in an int. Okay. Blue hair color. How would I store blue in a variable? How would I store blonde? How would I store brunette? How would I store those in variables? Those would be strings, right? So yeah, exactly, strings. So start thinking about how we might build up these objects. Okay, Cool. So how would we encode that? Well, you've already seen actually something that would allow you to create this kind of structure. Okay. Oh, cool. Let's also give our people names. So each of our objects is also going to have a name here. Okay, person 1, person 2, person 3. Okay. So how would you encode this kind of structure? You've seen the thing that we would use to do this, and it's called a class. Okay, it's called a class. So you would say, okay, I have this class of things. I'm going to call this the person class. Okay, so I have a class called person. And person objects are of type person. Okay, so person 1 is a person. So person with a capital P. Okay. Person 2 is a person. Person 3 is a person. Okay, so we've got these. So we build up that idea. So from person, we can create different persons, people. Okay. Cool. So the top thing is what we call a class. Okay, person is what we would call the class, and person 1, person 2, and person 3 are what we would call objects. Okay, what we would call objects. So this is how we describe objects, basically. It's not a super complicated thing, actually. Okay. Cool. Now we're gonna have some new terms. All right. So objects. Another way to say object, you might hear them referred to as instances. Okay. Instances. Now don't worry about the change in words. They can be called objects or instances. They're synonyms. Okay. Why are they called instances? It actually makes a bit of sense. Okay, because you're kind of saying it's like the word instant. Okay, instant. So you can say in this instance, if you like, the person class is referring to person 1. Okay, so you could say person 1 is an instance of person. Okay. Another way of thinking about it is to say objects are instances of a class. Okay. So it's just a new word that you should get used to seeing. Okay. So if they say what is another in your test, for example, what is another word to refer to an instance, you could say object. All right. Cool. So these are treated as synonyms. All right. Cool. So we've got all of these objects, and as we were discussing, they have properties, right? So each of these properties are assigned a value for each of our objects, right? So they have a name. So this one's name is person 1, for example. So if I say person 1 dot height, okay, I want you guys to answer this. Person 1 dot height. What would we get back if I asked you person 1 dot height? What would we get back as a result? Okay, if I say person 1 dot height, okay, we get 1.8. Exactly. We get 1.8. How do you get that? Person 1 is an object, right? Our first object. This object. If I say person 1 dot height, we go to their height variable and we get back 1.8. Okay. If I say person 2 dot hair color, what do we get? What do we get if I say person 2 dot hair color? Blonde, exactly. And if we say person 3 dot weight, what would we get back if we said person 3 dot weight? 200. Yeah, 200. Okay, fantastic. So you guys understand this? These are what we call properties. Okay, properties or attributes. Again, just like objects and instances, we'll use properties and attributes interchangeably. Okay, but again, guys, the word makes sense. All right, properties is a good word to use to describe this. You wouldn't use anything else, right? Each human here has 3 properties about them. They have the property of their height, they have a property of hair color, and they have a property of weight. And an even better word, I actually prefer the word attributes. Okay, because each person has certain attributes, right? And it's exactly how you would use the word in describing the real world, right? You could say oh, can you describe some of that person's attributes? You might say, oh, they're a brunette, for example. Okay, so properties and attributes, they mean the same thing, and these words, they make sense. There's a reason we use them. Okay, you would call these attributes. Okay, so yeah, hopefully you guys understand now. If I asked you person2.weight, we would get back 75 kilograms, right? Person2.weight, we would get back 75 kilograms. Okay, cool. So we also know that objects don't just have attributes, right? They don't just have attributes and properties. They also have methods. Okay, they also have methods. So let's think about this. So if we go back to when we were thinking about the world, okay, we had a bunch of objects, and yeah, those different objects had properties and attributes, right? So or attributes, same thing. Okay, those different objects have attributes. So if I asked you about a cat, you might say, okay, cats have an attribute called fur color. Okay, what is the color of the cat's fur? Maybe they have a size attribute as well. Okay, so they've got these different standard things about them. Okay, but we saw that a cat object isn't just its attributes, right? A cat isn't just its fur color and its weight. It also can act, right? It can also act. It can jump around. It can run. It can eat. Okay. These actions, okay, a sort of or sequence of things that an object can do are what we would call methods. All right, what we call methods. So in our example here, if I asked you person1 dot run, okay, dot run. So run there is a method, and you can see it's a method because it's got those two little brackets after it. Okay, so if I told you person1 dot run, you might expect, okay, if you say person1 dot run, you would expect an object with person1's properties, right? Blue hair, a specific height, and a specific weight. You would expect to see that person running. All right. So that's what the methods do. Okay, they sort of encode a way for the object to act. Okay, to act or to do something. So they aren't just attributes. Objects can also do stuff. Okay, and those we would explain in methods. Okay, cool. So that is the intuitive understanding of object-oriented programming. Okay, I think. Oh, okay, we're a bit early. So I'll go to the next slide already. So this is an intuitive understanding of object-oriented programming, but I also want us to get, obviously, the C# understanding of object-oriented programming. Okay, so how would we actually do this in C#? So we are going to, after the break, go into C#, and we're actually going to create this person class, and we're going to create 3 persons with these different properties, exactly like we've got here. So we're going to basically encode the structure inside C#. All right, and it won't be. I think you guys will be actually surprised at how sort of convenient this is, how easy this is to do in C#. Okay, and while we're doing that, we're going to learn some things. Okay, we're going to learn specifically some words. Okay, that would come up in a test about object-oriented programming. Okay, so the words I want you to know by the end of this lecture, and more importantly by the end of our next sort of session after the break, is constructor. Okay, we're going to know what a constructor is. We're going to know what static means. We're going to know what public means. We're going to know what private means. And we're going to know what getters and setters are. Okay, these are the important words to know when we're creating our own class. Okay, so now you guys already know what a class is, you know what a method is, and you know what properties are. Okay, these are some other words that we're going to get to know the meaning of. Okay, cool. So we're going to start with that. I think, yeah, let's take a break. It's a bit earlier than usual, but I think it's fine. yeah, we have been going for 50 minutes, so I suppose that's quite reasonable. Usually we do 60 minutes then break. Now we're doing 50 minutes break, 60 minutes. Okay. So yeah, we'll reconvene at 3, let's say. Seems good. Can you put the words back on? Yeah, exactly. Actually, I do want you guys to note down these words, okay, and give yourself a little bit of space after each one for like a paragraph, maybe, where you can explain your understanding of the words as well. But also, feel free to follow through in your book. Yeah, feel free to follow through in your book as well. Like constructors are on page 35, so we'll probably get there. So understanding methods was the bottom of page 34. We're through that, I think. And understanding constructors is page 35. Let me just see the chat. So we come back at 3. Yeah, 15. Okay, 3. See, we got another message. No, 3. I mean, like 1,500 hours. You know what I mean? Yeah, I guess that would have been confusing. No, but a 25-minute break is definitely too generous, I think. So this would be like a good 8 minutes. Okay. But yeah, I'll see on the group about maybe moving this to a different day or time. Because there's like 17 people on the group, and even on days with good attendance we have maybe 10 or something. So maybe it's because people can't arrive at specific times. Could also be that their connections aren't good and that they're just watching the YouTube video instead. Because I see the Roosevelt videos do have the best views of the 3 schools I do. Okay. Yeah, I guess they... Yeah, that's true. That's true. But maybe, yeah, maybe moving to a different day or time will help a few people. Even maybe a bit later on Mondays could work. Yeah, I'm going to throw them all into a playlist now, because it's a bit annoying some of them being on Google Drive and some of them being on YouTube. But I set up playlists for Bryanston and Crawford, and I'm going to set up your Roosevelt playlists today. Okay, yeah, let's get started again. Cool. So, yeah, we're gonna construct this exact class, okay, inside C#, this class and these 3 particular objects, okay. We might not do the run method, but maybe a simple print statement. We could do a print, okay. So we'll do some kind of run method just to show you guys what that would entail. Okay, and we're also going to have a particular focus on these words, okay, what these mean and how they affect our class. Okay, same, but I just got... Okay, cool. So... okay, you're back. Awesome. Okay, so we're going to be creating the person class with a particular focus on those words in the slides. Okay, so we don't need these yet. Let's just start by creating this class, right? The basic structure for this class. Okay, cool. Okay, so the first question would be, what is the name of our class? Okay, because you can see already from this, when we're creating a class, pretty much, so the first word is class, as you'd probably expect, and then immediately we run into the problem of, okay, what are we going to call our class? Okay, we already know what our class is going to be called, right? It's going to be person, okay, with a capital P. And in general, guys, when you're naming your classes, the first letter is the first character is always a capital letter, okay? A capital letter, and after that it's up to you. Okay, so there we go, we've created the class person, as simple as that. Okay, I'm just going to give myself space so the code we're writing can be on the center of the screen. Okay, so we've created the class person. Alright, good start. The next question is, okay, well, what properties will a person have? Okay, what properties will a person have? So, we know our persons have 3 properties, right? They are height, hair color, and weight. Okay, let's do weight, height, hair color. Okay, so we'll have a weight property, we will have a height property, and we will have a hair color property. Cool. Now, when creating attributes and properties, guys, the key thing to remember, I suppose, or you won't really have to remember it, is that it's exactly like creating normal variables. Okay, so each of your properties requires a type and a name. So we have to decide on the type and name of each of our properties. We've already given them names here. What is weight's type? What will weight's type be? And I want you guys to tell me. What will weight's type be? Ints. Yes, it'll be int. Okay, so all of our properties are just variables. Okay, so weight will be an int. What would our height property type be? What would height be? Think about just what they store. Okay, what would we use to store height? There's two choices here. Bonus if you can name both of them. Okay, double is definitely one of them. What would our other choice be if we wanted? How else can we store these decimal numbers? Not a long. Longs can't store decimals, can they, Bryn? They're just long numbers. Long integer numbers. Char. What do chars store though, Taddy? What do chars store? Just single characters, right? Char stands for character. You wouldn't use that to store a number. So you need to think about what is double of what, right? It has double the precision of a. There's some other type. There's some other type that it has double the precision of. So int, the longer version of int is long. The longer version of int is long, but not. That's the one. Okay, it took us a while to get there, but yeah, we could use double or float. In this case, we are going to use double. Okay, so floats also hold decimal numbers, so remember that, guys. So, and then lastly, hair color. So hair color is going to be like blonde, brunette, or blue. So what type would we use to store something like that? String. Yeah, exactly. Okay, string. Cool. So we've got our three properties, and our three properties all have types. Okay. Yeah. Cool. So actually, it is. There's obviously some technicalities still, but really it is that simple. We've now created a class with three properties. That's it. I can't really think of a better way to do this, really. I think C# has done it quite well. I hope you agree. It's very sensible to do it this way. Right? Very sensible. So, now we come on to our first word, because obviously now we have a problem of, okay, so we've got a person class, okay, and each object of type person has three properties: weight, height, and hair color. But we haven't yet told the computer how to actually go about creating a new person. Okay, so when I actually create an object of type person, how does it know, okay, I must make weight equal to this, height equal to this, hair color equal to this? Okay, so how do I actually construct or create a new person? And this brings us to the first word on our list. Okay. Constructor. Okay. Constructor. A constructor is a method that explains to the class, that tells the class or tells the computer how to create an object of that type, okay, of that class. Okay, how to create a new object of this class. We would use a method called a constructor. Okay, so we need to create a constructor for our person class to tell the computer how to construct an object of type person. Okay, so that's what the constructor will do. How do you actually construct a person or create a person? And there's more rules to learn about constructors, but they are quite simple to create. Okay, so you only need two words basically. Okay, so we'll have public. Okay, so they have to be public. We're going to go into just now what exactly public means, okay, and why this has to be public. Okay, but for now, just take it. Okay, it's public. Okay. The next thing, and this is actually quite cool, is this method, your constructor method, has the exact same name as the class. Okay, so our class is called person, so you literally just copy person, copy the name of your class, and you just put it down there. Okay, you can type it as well if you want, but it's exactly the same. The name of your constructor method is identical to the name of your class. Okay, so we have class person, and then our constructor is created public person. Okay, it's a method, so you need the two normal brackets. Okay, has the two normal brackets, and then we've got our two curly brackets, right? As usual. So that's our constructor. That's our constructor. So this will tell this method, its purpose is to tell the computer how does it construct a person. How does it construct a new object of type person. Okay, everyone's still following so far. Okay, so thinking back to when we created our last method, right, our adds two numbers method. It took in two numbers, right, the two numbers it had to add. Okay, how many variables? So remember, when we were creating our adds two numbers method, we had like int a and int b, right? The two numbers we wanted to add, we would put them here. Okay. How many variables will we need this method to take in to construct a person? Okay, Taddy says 3. That's correct. Yeah, that's correct. This will have to take in three variables. Okay, and also we know what their types would be. Okay, what would the types of the three variables be, Taddy? To construct a new person, we need three variables. And what do we need their types to be? What should be the type of each of our variables? Our first variable would need to be n. What would it have to be? Okay, we know we need 3. So int, double, and string. Oh yeah, okay, cool. Yeah, exactly. Sorry, I didn't see that you had sent that. Okay, cool. So we need 3 variables. Okay, int, double, string. Okay, so how do we specify what variables come into our methods? Exactly like with the adds two numbers method, right? So we say int, okay, int, we need to give it a name. What is the person constructor? What is the constructor going to call this variable? So for now, we can't call it weight. Okay, we can't call it weight because weight inside our person class weight already exists. Okay, so I'm going to call it w. Okay, so int w, we're going to need a double, right, for the height. Okay, so I'm going to call that double h, and then we need a string for the hair color. So I'm going to say string hc for hair color. Okay, so we're taking in 3 variables into our constructor for a new person. Okay. Cool. And now the rest of what this constructor has to do is to just set the variables, right? So we give our constructor these 3 variables. You give it an integer, a double, and a string. And then it just goes, okay, it's going to set the weight variable, the weight attribute, the weight property, to the value, the integer value that you give it, w. It's going to set the value of the height attribute to the double that you give it, h. And it's going to set the value of the hair color attribute to the string value that you give it, hc. Cool. And yeah, that's it. That will allow you to create a new person. Okay, that is our class. All right. Now, we created 3 people, right? We said that we're setting up the exact example of the slides. Ooh, right. So big thing, we now know what constructor means. Okay, so we're there. We know what a constructor is. It's the method that explains to the computer how to construct a new object of this type. Okay, a new object in this class. Okay, and it has the exact same name as the class. Right? Cool. So, let's think about this. So, we have this person class. We've created the person class. It has its 3 attributes. We now want to create these person objects, right? I want to create a new object of type person. Okay. So how would we do that? How would we do that? Well, essentially, when we created this class, we've basically created a new type. Okay. So when I want to create an object, it's almost like, initially at least, creating a variable. It's very similar. So you would say person, okay, that's the type, as it's the name of the class, okay. Person, you give them a name. The name of our first person was person 1. Okay, so let's create person 1. So we say person 1. Okay, cool. So now it changes a little bit, right? So it's exactly like a normal variable so far, right? When I'm creating an integer, I would say int x equals. Now I'm just saying person 1 equals. So how do we create person 1 now? Well, person 1. So the thing on the right, what do we need it to be equal to? What do we need to point it to? So we have the constructor, right? We've told person how to create new people, okay, a new person. Okay, so you just need to tell it to go and look for this. And how you do that is you say, okay, person 1 is equal to, and it's really nice that they use this word, person 1 is equal to a new person. Okay, a new person, and you type new. Okay, new person, and we have to give it the 3 things, right? This is calling the person the constructor, right? This is calling the person constructor, and we have to give it the 3 variables that it requires. Okay, so we have to give it person 1's weight, height, and hair color. So person 1's weight was 70. Their height was 1.8, and their hair color was, remember it's a string, so it has to be in quotation marks. Their hair color was blue. Okay. So we've now created person 1. Okay, that will create person 1. A new person. Okay. Now how would we create person 2? Well, it's the same. Now it's just easy, right? We would say person 2 equals. So we've just changed the name, and we still just say, okay, person 2, they're also a new person. Okay, and we have to give them person 2's details now. Okay, person 2, their weight was 75 kilograms, their height was 1.6, and their hair color is blonde. Okay, so 75, 1.6, quotation marks, blonde. Okay. Cool. And we need to create person 3 now as well, right? The giant. So person 3 equals new person, exactly like the other 2. Okay. And they also need their weight, which was 200, their height, which was 2.0, and their hair color, okay, which was brown. Okay, or brunette, rather, I guess is the technical term, right? Brunette. Okay. Cool. So we've gone and we've created the three objects that we had in the slides. Okay. Everyone okay with this? Yeah. Cool. Cool. So let me go and run this. See if that works. So if I click run. See, it runs. It doesn't complain. There's no errors. So C# understands everything I've written here. we haven't actually done anything yet, right? So we haven't actually done anything yet, but we have managed to create a class and give it all of these different values. So let's just remind ourselves what we've done here. Okay, so we created a class called person. Alright, created a class called person, which allowed us to define a sort of new type of thing. Okay, we told C# that a person has 3 attributes that you can change about them. Okay, a weight, a height, and a hair color, and we had to specify the types that these things had. Okay, we had to specify the types. That wasn't enough though, because C# also needs to know, okay, I now know that a person has these 3 properties, but when I create a new person, how do I set them? How do I actually set the properties? How do I create or construct? Think about it in that word. How do I construct a new object? Okay, so we had to define a method called a constructor, and what we know about a constructor is that it has the same name as the class. Okay, we told it the 3 variables it needs when creating a new person. Okay, so when you construct a new person, you have to provide the constructor with 3 values. Okay, and then you actually have to set the attributes of the person to those values that you specified. Okay, cool. And then we actually went about creating our 3 objects. Okay, 3 person objects: person 1, person 2, and person 3. We learned this new keyword, new. Okay, new. So you say person 1 is a new person, and these are their attributes. These are their values. Okay, their weight, their height, and their hair color. Weight, height, hair color, and it's the same every time whenever you want to create a new person. Okay, so that's what we've done so far. All right, cool. So now let's actually see what our person what this does. Okay, make sure that this is working basically. So when doing this, we're going to have to learn the meaning of a few new words. Okay, in particular, we're going to have to learn about what public and private mean. Okay, finally. So we're going to finally come to grips with what public and private actually mean. Okay, so let's try. So on this slide, when I asked you guys to tell me what person1.height was, and person2.hair color, and person3.weight, so you remember this little exercise was quite easy, right? Let's actually test this out. Okay, so if I said person1.height, we said I would get back 1.8, right? If I said person2.hair color, I should get back blonde. If I said person3.weight, I should get back 200 kilograms, right? This we defined this, right? So let's actually experiment with those exact 3. Okay, so I'd say console.writeLine. Okay, person1 dot. So we first asked about person1 dot height. Okay, so person1 dot height we're interested in. Console.writeLine. We were interested in person2 dot hair color. Person2 dot hair color. And we were interested in person3 dot weight, right? Console.writeLine. person3 dot weight. Okay. So now hopefully when we run this, it would go create these 3 new persons, and then it's going to tell us person 1's height, person 2's hair color, and person 3's weight. And you can see exactly how I specified it in the slides is how you write it here. Person 1, so the name of the object, okay, the name of the object is person 1, dot the name of the attribute you're interested in, height. Okay, exactly like that. Now when I run this, you're going to see why we're going to have to learn that first new word. Okay, when I run this, it gives me an error. Okay, 3 errors. Okay, so it's given me 1 error for each of these. Okay, so it told me person1.height is inaccessible due to its protection level. Person.haircolor is inaccessible due to its protection level. Person.weight is inaccessible due to its protection level. Okay, so what do we think it's referring to there, guys? When it says inaccessible due to its protection level, what 2 words do you think are relevant to protection level? Public and private, exactly. Okay, so what is C# telling us here? It's saying, no. When you create a new thing of type person and try to access person.height or person.haircolor or person.weight, you can't. Okay, weight, you're not allowed to see weight due to its protection level. So when we created weight, okay, so we didn't specify, right? I didn't say public. Okay, I also didn't say private. I didn't put either there, right? I just left it blank. We just said int weight. Okay, so what did C# do? What do you guys think? Did C# make it private or public? Did C# make these private or public? Yeah, it made it private. So when you don't specify what a variable is, if you don't say something is public or say it's private, C# will just assume it's private. Okay, so because I didn't specify, what C# did is it went and it goes private, private, private. Okay, so C# went and it put those 3 words there automatically. Private, private, private. Okay, it put them there automatically because I didn't specify. Okay, so you'll see now I've made them private. I've specified that they're private, and when I run this, you'll see it does the same thing. See, exactly the same. Okay, so what does this mean? And this is the whole meaning of the word. Okay, private means something is only accessible inside the class. Okay, so you see, it doesn't complain here, right? So when I say weight equals W inside person, it doesn't say weight is inaccessible due to its protection level. Why doesn't it say that? Because here when I access weight, I'm inside, you can see between these curly brackets, I'm inside the person class, right? I'm inside the person class. Okay, see, it didn't complain that height was inaccessible because I'm inside class person. It didn't complain that hair color wasn't accessible because I'm inside class person. But when I was outside of class person, when I was inside class program, okay, when I was here and I tried to access this person's height, then it complained. Because now I'm inside the program class and I'm trying to access a variable that is private to person. Okay. Cool. So now we see what private means. It means it's only accessible inside the class. Okay. So how would I change that? Well, if I just say public. Okay, what if I just go and make all of these guys public? Public, public, public. Okay, what does that mean now? So let me try running this now. If I click run, now it prints out 1.8 blonde 200. Okay, 1.8 blonde 200. So now this does what we expected it to do. Okay, because by saying these are public, I've gone and I've told C#, okay, these you are allowed to access outside of the class person. Okay, so when I try to access them inside the class program, it goes, cool, you're allowed to see those. Okay, it's so now what? Okay, so we've created three people. Okay, there's still quite a lot. Yeah, still quite a lot. I think we should be able to fill up these last 30 minutes with just the 2 words we haven't learned yet. Okay, So let's think about what public truly means here. Okay, we're saying this is a public variable. It is accessible outside the class. Okay, so we've seen it. When I say person1.height, it allows me to see person1. Okay, person1's.height. Okay, it allows me to see 1.8. Okay, when I say person2.hair color, it allows me to see the hair color. If I change these to private, it doesn't allow me to see them, right? Okay, but what about changing them? So if I say, so you see initially we say person1, their height is 1.8. If I say, okay, person1 dot height, okay, and I change it, so I say equals 1.2. Okay, so knocking off 0.6 of a meter. Okay, so we change person1's height. Okay, so then we print out the normal thing. So we create our three objects, okay, here in these three lines here. We then go and we say person1.height. Initially it's 1.8, right? I go person1.height equals 1.2. Okay, and then we print out our height, hair color, and weight of person1, person2, and person3. Okay, we print out person1's height, person2's hair color, and person3's weight. So now, if this change goes through, right, if we actually change person1.height to 1.2, when we print out person1.height, it's not going to print out 1.8 anymore, right? Here we said 1.8. This is not going to print out 1.8 anymore. It's going to print out 1.2, right? So when I run this, you can see it prints out 1.2. So it allowed me to change person1.height. Okay, we get that, right? I changed the attribute. Likewise, you could have said person2.weight equals 300 or something. You can change any of these variables. If you sorry, stay on page. If we used const, then we wouldn't be allowed to change them here. Okay, but you also wouldn't be allowed to set them inside your constructor. Okay, but let's not think about const right now, because trust me, this will be it might be weird enough. Okay, so what have we done? By making these variables public, we have said that, okay, you are allowed to change person1's height. Or rather, not just person1's. By making it public, we've said you can change a person's height, weight, and hair color. Okay, from any class. Okay, and you can view it. Okay, so by making the variable public, it's not just that you can see its value, you can change its value. Okay, that's the important thing I want you to get, guys. That it's not just that you can see the value when it's public, you can also change the value when it's public. Okay, you can also change the value when it's public. Okay, so after we set it initially, because it's public, we can change it. Which means I can kind of do some weird stuff now, right? Like, what if I made person1's height equal minus 1.2? Now their height is minus 1.2. Does that make any sense? No. Like, I could change their height to like 0.4. Is this something necessarily that you would want to happen? No, right? So, what if I want you to be able to see the person's height, weight, and hair color? Okay, so if you're in the program class outside of the person class, I want you to be able to see their height, weight, and hair color, but I don't want you to be able to change it. Okay, so I want you to be able to see their height, weight, and hair color, but I don't want you to be able to change it. Notice that we don't yet know a way to do that, right? Because if I make this private, so I say, okay, currently you can change the person's height, which means you can do a bunch of weird stuff, right? You could change any of their heights. But what if I don't want you to be able to change it anymore? Okay, so I say this is now private. So now you're no longer able to change height. We still have a problem, right? Because now you can't see height either. By making it private, it means you can't see it or change it. But by making it public, that means that we can see and change it. Okay, so we want a middle ground here. We want to be able to go, okay, you can see it, but you're not allowed to change it. Or you can see it, but you're only allowed to change it in specific ways, like you can't make it negative, for example. So how do we do that? Not yet. We will get to static. We'll get to static. I should have put it at the bottom. Okay. So what comes in now is the last one. Getters and setters. This is what they're for. Okay. So we're going to go back to either not specifying or specifying them all as private. Okay. That means the same thing. If you don't specify, they'll all be private. Okay. So we're saying weight is private, height is private, hair color is private. Okay, so now when I run this, it complains a lot, right? It goes, look, you're not allowed to change person one's height here, and you're not allowed to view any of these people's heights or hair colors or weights. Okay, you're not allowed to view anything, and you're not allowed to change anything when I change it to private. Okay, so now we want to create. This is what the last word on our list is. Getters and setters. Ooh, damn it! Why did I do that? That was so silly of me. Our last word on the list was getters and setters. That is what they are for. Okay. Open that guy. There we go. Sorry about that. Okay, yeah, our last word on the list, getters and setters. Problem of putting so many animations in. Okay, so we've got constructor. We don't yet have static. We've got public and private, right? Public means it's accessible and changeable anywhere. Private means it's not accessible or changeable anywhere. So now we get getters and setters. Okay. Getters and setters are what will allow us to control this. Okay, so getting, and getters and get stuff. Okay, so they'll get the value of weight, and setters will set the value. Okay, another word for these, you can call them accessors and mutators. So instead of getter, you can say it accesses. It's an accessor. And instead of setter, you can say it's a mutator. It mutates the value. Okay, so accessors, mutators, getters, setters. Okay, how do we create these? Cool. So it's actually quite similar to how you create a constructor. So notice, it's public. Okay, the constructor is public. Why is it public? Because we have to be able to access the constructor here, right? We have to be able to access the constructor outside of the person class. Likewise, our getters and setters have to be accessible outside of the person class, so they have to be public. Okay. You have to give them a return value. Okay. What will your getters and setters return? So, let's start by creating a getter and setter for weight. Okay. Let's start by creating a getter and accessor for weight. What will this return? What is its return value? What type will it return? Can you guys tell me? What type will a getter and setter will our getter and setter for weight return? That's a value, not a type, right? That's a value. What is weight's type? What is the type weight? Int, exactly, int. Okay, everyone's got that. All right. So our getter and setter for weight is going to have a return type of int. Okay, and then the standard is to take the name of the variable when you're creating the getter and setter. Take the name of the variable and just capitalize it. Okay, so weight with a capital W. Okay, public int weight. Okay, I then say, all right, we specify the normal curly brackets. Okay. Ooh, need more water. And we've got two things, right? Getters and setters. Okay. So all you say is get. You specify the two normal curly brackets, and set. Two normal curly brackets. Okay, like that. Public int weight. Get set. Okay. Now, get is just going to return the weight attribute, which is an int, right? So that's fine. And now you think about what's happening here. Okay. So we say public int weight. So we're creating a public method, right? Weight is accessible outside of person. Weight with a capital W. Capital W is accessible outside of person. Weight with a little w, so the attribute weight, is private. It's only accessible inside person. Okay, so we can access weight outside of person, and it just returns weight with a little w. But now you see this weight with a capital W is inside person. Okay, so it does have access to weight, even though weight is private. So that's what's happening here. This is why the getter works. Okay. And the setter just sets the value of weight. We go weight equals, and this is just a magical variable that C# has called value. Okay, that it'll just pass to set. Okay, so we say value. This is just magic. Okay, occasionally programming just has magic as well. Okay, so we just take that as being magic. Alright. Cool. Just C# just knows what that means. Okay. Cool. So we've now created a getter and setter for weight. Now if you guys don't mind, I'm going to change height and hair color back to being public. Okay. So height and hair color are public. So it's not going to complain about height and hair color here. So when I run this, you see it won't complain about height. It only complains that person1.weight is inaccessible due to its protection level. So you see here I say, person.weight. You see here I say person3.weight with a little w. If I now go and change this to a capital W, person3.weight with a capital W, okay, capital W, it's now going to access this method which is public. And now I have access, and now it runs perfectly fine. Okay. And now it runs perfectly okay. Alright. Because now I'm accessing the capital W, and you see capital W is public. Okay. So even though the variable itself is private, I can still access it now from my getter. Okay. Do you guys get that? Are you okay with what's going on there? Get set. So these are called getters and setters. They're just special types of methods. Okay, special things that can exist inside a method, and you guys get that. Awesome. Okay, so that allows us to access, but you can see we can actually also change weight now. So I'm going to say person 3.weight, so they were 200 kilograms, right? When we initially create person 3, they are created with 200 kilograms. I'm going to say person 3's weight actually equals 100. Okay. Notice when I change weight, I say person 3.weight with a capital W. Okay, capital W. And I change it to 100, and then when I access it, I also access the capital W. Okay, so I'm accessing this, not this. Okay. Cool. So, person 3.weight, alright. Now I'm allowed to change it and view it. So when I run this, you can see person3.weight with a capital W is now 100. Okay, it's now 100. Even though it started at 200, this line allowed me to change it, okay, to 100, and then we accessed it. Okay, even though weight is private. Look, weight is private. Private int weight. The getters and setters, because the getter and setter is public, I can change it and see it from outside the class. Okay. Now, remember the question we were asking. We were saying, okay, I want you to be able to change it. I want you to be able to see it, but not change it. So you can see the person's weight, but you're not allowed to change the person's weight. Well, it's quite simple now, right? I would just remove set. If I just remove set, you're no longer allowed to change the person's weight. So when I try to run this, you can see it won't allow me to change weight. This line here, it won't allow that. Okay. So now you can see the person's weight because of the getter, but because the set is gone, you're now no longer able to change it. Wow, you are very late, Dape. Okay. So, yeah, get set, ready, go. Okay, but yeah, we have... Okay, so because we removed the set variable, you're no longer able to change weight, but you can still view it. Okay, so, guys, you've heard of read-write permissions. Have you guys heard of that? Read and write permissions. You've heard of this. So you can read things, right? So you might have... Okay. If you've ever worked with like Word documents or something, it's possible that you're allowed to open the Word document and like read all the text that someone else wrote. Okay, so you're able to read everything that someone else wrote, but you're not able to change it. Okay, so this is called read-write permissions. You're able to read something without being able to write to it. Okay, so you can't change it, but you can view it. Okay, and how that's enforced is with getters and setters. Okay, so you see, I've made weight private, so usually you would not be able to access it, and you would not be able to view it, read it, or write it. Okay, because it's private, you're not able to read it or write it. But because I added this getter here, you are able to read it. Okay, if I wanted you to be able to write to it, I would have to add the set variable. The setter. Okay, set weight equals value. Okay. So now you would be able to get it and set it. But if you remove the set, then you're only able to get it. Okay, so this is how you could go, okay, you're allowed to read it, but not allowed to write it. Okay, or you're allowed to read it and write it. Okay. But this also allows you to do something else that's quite cool. We do have time with it, but actually I want to explain one more word first. Because we still have to explain, I think we still have to explain what static means, and we still have to, actually there's one other word that I want to explain to you guys as well in these last few minutes. Yes, exactly. If you made them private, Tuddy. If you leave them as public, then you can think of them as already having getters and setters. But if you only have... If they're private variables, then in order to change them or see them, you have to add the getters and setters. But remember, sometimes you would just want the variable to be private, right? Sometimes there's going to be... that's cool, Dape. That makes sense, definitely. You're not going to get much from only watching the last 10 minutes. Tadi, sometimes you would want it to only be accessible inside the class, right? Sometimes you don't want getters and setters. There are some things that are private, like if you had a class for a user account, for example, like they have a username. So the username, you would want it to be private, and you would want it to have a getter, right? So a username, we would want it to be private, but we would want it to have a getter. So other people must be able to view my username, right? That makes sense. They must be able to see my username, but they mustn't be able to change it. So it's not going to have a setter. Okay. But a password, what about my password? A password field, that's totally private, right? They mustn't be able to get it or set it. Okay. So that will have no getters or setters, and it will be private. Okay. So it still depends on how you want this to be accessed. Okay. In general, we'll always make, like C# does, right? If I don't specify whether height is public or private, it's private. Okay. And in general, for all variables inside classes, for all the attributes of classes, we want them to be private, usually. Okay. Almost always you want to make them private, and you want to go ahead and add the getters and setters. So let me do that. Okay, I'm gonna go add public. What will the return type for heights, getters, and setters be? Anyone know? Double, exactly. So double, we say height with a capital H, okay? And we put our normal curly brackets here, and we can throw in the getter and setter for height. Okay, so gets. Okay, and that's going to return height. Okay, and set, we're just going to say height equals value. Height equals value. Okay, magic. And we need hair colors one as well, right? What will the return type for hair color be? What will the return type for hair colors, getters and setters be? Hair color is a string, right? So it's going to be a string. Yeah, cool. So we say public string hair color. And we add the getter. Okay. So you can see this is a lot of typing, right? Just to make your variables private. But we're going to see that C# actually does have an automatic way of doing this. But we're only going to see that next week. Okay. So this returns hair color and set. And this just says hair color equals value. Hair color equals value. Okay, there we go. So now our variables are private, but they have their getters and setters. So we're able to see and change all of our attributes. Okay, see and change all of our attributes. Right, great stuff. So now, 2 more words I want us to learn in the last 9 minutes. Okay, they're very simple words. Actually, yeah, we should maybe save static for next week, I think, because it's slightly disconnected from this stuff. Okay, so I'm going to teach you the meaning of one more word. All right, one more word today, and it's just a nice little trick, basically. It's just a trick that is slightly more convenient to write code with. Okay. So let's do this. All right. When we look back at our constructor, okay, our person constructor, so this is how we create a new object of type person. How do we know it's the constructor? Because it has the same name as the class. Okay, the constructor is the method that has the same name as the class. Okay, so this tells us how do we create a new person. Okay, notice here we said int w double h string hc. That's not really that nice, right? It would have been much better if I could say int weight double height string hair color. Okay, so look, if I did this, int weight double height string hair color, that would be way better, right? It makes way more sense now that we're taking in these 3 variables. Okay, makes way more sense. But now when I say weight equals W, I can't say W anymore, right? I said W because this was W. I now have to say weight. And here I can't say H anymore, I have to say height. And here I can't say HC anymore, I have to say hair color. But now you can see that obviously the computer is confused, right? The computer will get confused. And you can see why, right? When you say weight equals weight, is this weight on the left or is this weight on the left? Which weight am I changing? Here if I say height equals height, is it this height that I'm changing or is it this height that I'm changing? When I say hair color equals hair color, is it this hair color that I'm changing or this hair color that I'm changing? Okay, so this extra word is just a trick. It's just a trick that allows you to do this. Okay, it's a trick that allows you to name things the same way and still tell the computer which thing you mean. So you have to tell the computer, basically what we have to say is, when I say weight here, I mean this weight. Okay, when I say height here, I mean this height. When I say hair color here, I mean this hair color, as opposed to this one, and this one. Okay, so I mean, when I say this weight, I mean the weight inside class person. Okay, this weight. Okay, why am I saying this so much? Well, because the word is this. Okay, that's the word we're learning. The word is this. So just maybe add it at the bottom just under getters and setters. We'll come back to static next lesson because it's slightly freaky. Okay, so if I say this dot weight, what this means is it's saying, okay, when I'm saying weight here, I mean the property, the attribute weight inside class person, as opposed to meaning this one or any other weight. Okay, so this allows you to refer to properties and attributes. Okay, this dot hair color. Okay, and you'll see now this still expected a. Where did I leave out a semicolon? Oh, there I did. Whoops. When writing up all those getters and setters. Easy to make mistakes when we write up so many things at once. Oh, and these now have to be caps, right? There we go. Sorry about that, guys. Cool. So you see this still works. Okay. What does this mean? Okay, so it means that it's accessing the attributes inside the class. But yeah, Dapper, watch the rest of the video in order to understand. Okay. So you see we've got these attributes inside this class. Okay, inside class person, a person has weight, height, and hair color. And when we say this weight, we mean the person class's weight. Okay, this weight, as opposed to any of the other weights that we've defined. Okay, it's a bit of a trick. It's the reason why I saved it for the end, okay, guys, because it's not super essential. But just know that this keyword does exist. Okay. So you can, in fact, name variables in this way. Okay, you can call them the same thing when you're creating your constructor. And note, you can use this anywhere. Alright, if I say this dot weight, that's totally fine. Okay, it doesn't have to be in the constructor. It can be anywhere in your class. Okay, and it just means that we're talking about the variable inside the class. Okay, so you can say this dot weight instead of weight. Okay, so it's just a more specific way. If you remember at the beginning of the lecture when we created our add two numbers method, at one point we said program.add two numbers, right? And we were in the program class. It's kind of similar to doing that. It's like saying, look, it's being more specific. You don't have to do it. It's just being more specific. Okay. So you can just be more specific, and then you're allowed to name the variables in the same way. Okay. Cool. I think we could explain static, but that means we would probably go massively over time. So I think let's call it there for this week. I am going to schedule the next lecture probably before the day, okay, because it works more nicely on my calendar so I don't get like shocked. But I'll I'm gonna send a message on the WhatsApp group for everyone to like vote if we want to change times, because I'm a bit worried because a lot of people seem to be missing. Okay, so we might be switching days or switching to a later time or something. Okay, cool. Yeah, cheers, Taddy. Goodbye, everyone, and see you next week. Okay. Yeah, see you next week. Probably at 2, probably on Monday, but we will see. Okay. And yeah, I'll upload the video right after this as well. Okay. Yeah. Cheers, guys. Let's see who's going to be our new host. Okay, I think Bryn's gone. Okay, Taddy is the new host. Goodbye, everyone.